So hi guys, so today we would be looking at the second part of the reinforcement learning along with TensorFlow agents series. So in the last video I told you about some awesome applications of reinforcement learning and how TensorFlow agents basically helps making reinforcement learning and coding part really easy. So coming to this video, in this video we would be building a deep Q network agent on the cardpool environment using TF agents library. Don't worry if you don't understand a lot of terms. It's gonna be a very fun session. We are going to understand each term, and I would walk you through all the components in RL pipeline for training, evaluation, and data collection. So let's first talk about this. What am I saying? That deep Q networks. So basically, it works something like this. This is a state, and this is a deep neural network. I guess you all have already uh, heard about deep neural network if you are watching this video, so you know how it works. So you can assume it's something like this: a deep neural network which is mixed with uh, reinforcement learning algorithm, and the outputs are now getting diverted, or I would say getting results as part of the deep neural network. So yeah, after the state, here you can see the deep neural network is performing the thing, the training part and everything, and a queue value action 1 comes, action 2 comes, action 3, and actions come, and then you just get an overall result. So we are trying to train that only. So now what is this environment? So basically OpenAI means, if you have heard of this library, I would just show you image IO library, this TensorFlow Piglet we are using, and we are using Cartpole environment. So when it comes to OpenGym, there are a lot of environments presented specifically for reinforcement learning. So I would just go here and I would just type OpenGym AI suite, and here this is the GitHub page of their uh, whole code part. So here you can see that this particular library helps you in uh, developing algorithms for reinforcement learning. So here you can see it is an open source Python library for developing and comparing reinforcement learning algorithms by providing a standard API to communicate between learning algorithms and the environment. So there are a lot of environments present here. You can just go here and just see, like, here are the tests. If you go here, here's the gym part, and you can see all the environments which are present here. So you can see box, classic control, toy text, a lot of environments are present here. So you can go inside any one of them and just explore it. So I would leave it for now. So we are taking the as I told you, we are taking the cartpole environment for now, using the TF agents library. So we have installed all the things here. You can see image IO, PyVirtual, the TensorFlow agents, and the Piglet. I don't know why I said Piglet again. It's Pyglet. So then we are importing all the things, the TensorFlow agents, the policies, all the things we are importing here. Not something you need to worry about. You can simply go to the documentation and learn how to basically learn about and keep remember all the things. Then we are using display, virtual pi virtual display, for seeing the environment with our own eyes to make sure the visualization looks good. And then we are defining some hyperparameters like the number of iteration, the initial collected steps, batch size, learning rate, log interval. A lot of things which you are seeing here are part of the basic training model things. So yeah, so in reinforcement learning, as we have already studied, that an environment represents the tasks or problem to be solved. So standard environments can be created in TensorFlow agents using the TF environment suites. So TF agents has suites for loading environments from sources such as OpenAI Gym, Atari, and DM Control. So we will load the cardpool environment from OpenAI Gym suite. So this is the environment name, and we are just going to load it. So yeah, it's been loaded. So we can render this environment to how it looks. It is a free swinging pole attached to a cart. The goal is to move the cart right or left in order to keep this pole pointing up. So I would just do it, and here we go. We have got some result here. You can see a free swimming pool which is attached to a cart. From the name itself, you must have got to know. So the environment step takes an action in the environment and returns a time step tuple containing the next observation of the environment and the reward for the action. So the time step spec method returns the specification for the time step tuple. So we would just look at all the things. So now once we have defined it, I would just take you up here again. You see here, this is the environment name and this is the environment which we have defined here. So we would do all the operations on environment now. Okay, so we would just see the time step spec and observe it. So yeah, you can see the name of observation, the minimum, maximum, all the values you get here. So it's basically observing the attribute shows the shape of observations, the data types and the ranges of allowed. So it returns the specification for this time step tuple. Okay, so now comes the reward part. This was observation, this is reward, and here it comes. The d type, the name, everything is there. So if you remember, when we learned about reinforcement learning, it was pretty clear that a lot of things is done in reinforcement learning, and two important things were reward and observation. The observation part plays a very crucial role because the environment observes, means the agent observes from the environment and then performs a specific action, and the reward is given accordingly. So once that's done, we will print the action, return the shape of the valid actions that are allowed, and yeah, here you go. Name action, minimum 0, maximum 1. Either it's wrong, either it's right. So simple as that. So in the cardboard environment, the first is observation is an array of 4 floats: the positive and velocity of the cart, position I mean, and the angular velocity, position and velocity of the pole. Reward is a scalar float value. Action is a scalar integer with you have only two possible values, that is either left or right. So it depends where do you want actually to make sure things happen. So we would just reset it and that print all the things. This is the action, this is the step, and we have done this. Yeah, so here you see things. This is the time step. This is the time step for observation, the discount, the reward, the step type, all things are mentioned here. And as you can see the difference in the value. Now usually two environments are initialized, one for training and one for evaluation. Just like we do in supervised learning, we basically train one model, we keep some data for training and one for evaluation. So same we would be doing here. This is the training and this is the evaluation. So we would be just loading it, and yeah, we're good to go. So the cardpool environment, like most environments, is purely written in Python. So this is converted to TensorFlow using the tfpy environment wrapper. The original environment API uses NumPy arrays, so we would be converting them using tfpy environment. If you don't know about this library, I would just show you. I have just searched for it once. You can see. So this library is specifically for TensorFlow agent part. This helps in exposing a Python environment as a graph TF environment, because TensorFlow uh, works in graphs and stuff. So yeah, we have done that. So now the algorithm which is used to solve this RL problem is represented by an agent, and a TF agent provides standard implementation of variety of agents, including a lot of them. You can just go. So this DQN, which we have already, deep Q neural network. So the DQN agent can be used in any environment which has discrete action space, and as a heart of DQN environment is Q network, a neural network that can be learned to predict at Q values. If you have seen things above, you must have got an idea what I am talking about. The Q values which we are getting here, we are training a deep neural network to learn about those Q values. So not that hard, I guess. Now what we are going to do, we will use tf.agents.networks to create a Q network. So this network will consist of tf.keras.layers as usual, where the final layer will have one output for each possible action. So here you go. We have defined the action tensor, the num actions. We have already defined the parameters actually. So we'll define a helper function to create dense layers configured with the right activation and kernel initializer. And this is the dense layer. We are returning the tf.keras.layers, the num unit, the activation function, everything looks good. And the scale, the mode, we have already defined a lot of parameters above, so that won't be a problem for us. And now Q network consists of a sequence of dense layers followed by a dense layer with num actions. So this is dense layers, the Q value layer, and we have defined everything here, so it looks good. Now we would use tf dot agents dot dqn dot dqn agent to initialize a dqn agent, and in addition to get the time step action and the observation thing which we were talking above, the agent constructor also requires an optimizer. So we are using Adam in this, a loss function and an integer. So I would just do that, and this optimizer, the agent we have defined here, and we have initialized it. So I'm keeping this for this much for only this video, because there's a lot to come even after this. So not to get you guys confused, I would just stop this here. I want you guys to do just a small thing. Just go to this notebook, try to understand things by your own. Even this TensorFlow agent part is a bit complex for even need to explain you guys, because it's like you know the things, but sometimes sometimes the topics are like that. It's really hard for you to explain to other guys. Even though I've tried my best to wrap up things in the most easiest way I could. So if it's possible for you guys, just go to this notebook and try to study this notebook using your own mind and searches and knowledge. You may find it helpful. And yeah, so that's it for the today's video. I hope you have got to know something new from this. uh, do like and subscribe the channel. It would help me grow the channel at a good pace. So thank you and have a nice day.